Let's have a look at some more examples applying the rules of differentiation. We've got dx of 2 over 3x to the 4. So now this is the first example we're working with where we've got an x in the denominator of your fraction. And remember, as I said to you, you can't apply the rules of differentiation until you've brought those variables up into the numerator. So while we're doing that, remember, now you've got to be careful. You're not applying any rules of differentiation yet. So in terms of the notation, you've got to keep writing dx until the point that you're applying the rules of differentiation. So this x is coming up to the top, and it's now x to the negative 4 over 3. The 3 is not a problem. That can stay right down in the denominator. It was just the variable. Now that we've done that, now we're applying the rule of differentiation. So it's at this point that we just say equals, and we apply law 1. And law 1 said negative 2 times 4 is negative 8 x. And if I subtract 1 from negative 4, we're landing up with negative 5 over 3. Once we've done that, we generally don't leave an exponent as negative. So once we have applied the rule, we just finish it off by actually then bringing it back down where it becomes a positive 5. Okay, so once you've applied your rules, don't leave your exponents as negative. All right, something a little bit more exciting. Let's see what we've got over here. I've got an 8 root x. Okay, so problem number 1, I've got a third. Minus 1 over 2x, problem number 2, I've got an x in the denominator. Plus 3m to the 4. Now that's a problem in itself, because where does m come from? Okay, m is now this totally different variable, which it confuses people, because they're like, well, hang on a second, I'm supposed to be solving for x here, and now this m crops up, so what am I supposed to do with it? Wait, and I will show you. Okay, so are we allowed to apply rules of differentiation yet? The answer to that is no, because you've got problems and problems. So we're keeping our notation as just f of x for now, and we're going to fix the problems. Instead of the root of x, I need to change it back to an exponent, so it's going to be x to the half. This x is going to move up into the numerator, so it's going to become x to the negative 1, and it's still over 2, all right? And then we've got this 3m to the 4. Okay. Right, now we're ready to apply the rules of differentiation. So I'm going to say f prime x equals, and we apply law 1. 8 multiplied by a half, that's going to be 4x. Now, I was going to write it in a different color. If I subtract 1 from a half, 1 is the same as 2 over 2. So 1 over 2 minus 2 over 2 is giving me negative 1 over 2. Just make sure you get that right. And then we got negative 1 multiplied by, now remember this negative belongs to the coefficient of your x. So negative 1 times negative 1 becomes positive 1. And then that's x to the negative 2 over 2. And then this guy over here. Now, I know it's got a variable in it, but there are no x's, okay? So because there are no x's, it basically gets treated like a constant term. It just falls away, okay? So if you don't have an x in a term and you're trying to find the derivative, that's what happens. It falls away, even if there's other variables. Okay, and that pretty much leaves us now with the derivative. Now we can just tidy things up a little bit. Don't leave that as a negative exponent, rather bring it down underneath your 4 and it becomes a positive a half. Again, also don't leave that as negative. Let's rather bring it down to where the 2 is in the denominator and it becomes 2x squared. You can go one step further here regarding that x to the half. At this stage now we can put it back in third form. So we've got 4 over, you can write it now back as a root of x, and oh, actually this can cancel, that x cancels with 1 of, wait, what did I do there? No, let's just correct myself there. We need to correct myself there. When that came down to the bottom, there was no x, it was just 2x squared. Okay, let's just make sure that's clear. So this one here is going to just stay as it is. So we've got 1 over 2x squared. Okay. All right, so there we go. That's a little bit more complex, working out your derivative where you had a couple of issues to deal with to start off with. Right, what have I got here? Looking for the derivative in terms of x. And straight away I can see, well, I've got a surd that I have to get rid of. And then just also taking note of the fact that this whole bracket is getting squared. Okay, so you need to get rid of the brackets, and then once you've done that, you need to get rid of that surd. All right, and pretty much in that order. So dx, the derivative in terms of x, we're going to keep it as that because we're not finding any rules or applying any rules just yet. And basically, if I'm squaring something, I'm going to multiply it out twice. Well, this is my opinion. I think it would be easier to leave your surd as it is for now. Do the FOIL with it in terms of a surd and then change it to exponential afterwards. That being said, if you want to change it to x to the half at this stage, you can. It's your preference. Okay, you can do it if you want to. All right, so we've got dx of x times x is giving me x to the 4. Negative, if I do outers, I've got x squared root x. If I do inners, I've got negative x squared root x. And a root x times by a root x, remember whenever you multiply a surd by itself, the surd falls away and we're just left with the number which is just x. Okay. Right, so just taking it another step of clearing it up. That's going to give us negative 2x squared. Okay, this time now, instead of writing root x, I'm going to say x to the half, okay, plus x. And we need to obviously deal with that. That doesn't look great. So let's just fix that up. If I'm multiplying bases, I add my exponents. So 2 plus a half is 2.5. But don't leave it as a mixed fraction. Change it to improper. So what do I mean by that? X to the, instead of saying x to the power of 2.5, I've got x to the power of 5 over 2. Much more user-friendly. Okay. Okay, so quite a lot of processing, getting it all worked out, but now I'm ready to actually apply my rules of differentiation. So at this stage, we're going to say just equals, and then we work it out. So I've got 4x to the 3. 5 over 2 multiplied by negative 2 is going to give me just negative 5x. And if I subtract 1, remember 1 is the same as minus 2 over 2, we're getting 3 over 2 as my exponent there. And this is going to become, remember the exponent sitting above your x there is an invisible 1. So it's going to be a 1 and the x will fall away. Right, so we are pretty much done. The only thing I could really do further to this is I can say x to the power of 3 minus 5. And this basically could be written as the square root of x cubed plus 1. Okay. Right, so a nice interesting example there. Go back over that again. If any of that was a little bit uncertain, just watch it again. Just see how, and can you see how I've really tackled it step by step? I haven't done anything crazy and jumped steps and what have you. I've just processed it one step after the other. And that's really how you want to do it. Just tackle it carefully and methodically and you will get there. Okay, next one. Problems, what I see, I've got a root and I've got another root and then these brackets are being squared. Okay, so again, I need to get rid of the brackets. Once the brackets are gone, I need to get rid of the surd and then I can worry about the derivative. So we're leaving it as y equals for now. And remember we said that if you're squaring something, you are multiplying it by itself twice. Okay, so pretty much that's the case. So if I times them out, remember when you're multiplying fractions, all I need to worry about doing is timesing the top with the top and the bottom with the bottom. So root x times root x will be just x over 2 times 2, which is 4. Those are the firsts. Let's do outers. 2 times root x is 2 root x over the denominator, which is also 2 root x. Then let's do our inners. That's going to land up giving me 2 root x over 2 root x. And the last, 2 times 2 is 4 over root x times root x, which again is just x. Okay? Right, that looks good, but let's just deal with this. Anything over itself, we know is 1, so 1 plus 1 is giving me 2. And we don't want that in the denominator, so let's at this stage bring that up to the top, because it's now going to be to the x to the negative 1, okay? And by doing that, we're ready to find our derivative. So dy, the derivative of y in terms of x is equal to, the exponent above my x over there is a 1, so if it multiplies at the front, we're landing up with 1 over 4, and the x falls away. The constant term of 2 falls away. Negative 1 times by positive 4 is going to give me negative 4x to the negative 2. And the last thing we want to do then is make the exponents positive again by bringing it back down into the denominator. All right, there we go. Practice them again. Make sure you're doing them for yourself. All right, don't just watch me, work with me, because that's how you're going to actually process it for yourself. Okay, I will see you in the next video.